Hello and welcome to Module 8, where we are going to introduce radicals this week. This intro is going to be a little bit longer than normal because there's a little bit of background that you need to know. So you know this, but I'm going to make sure you understand this because this is going to lead straight to what we're going to talk about this week and for future weeks. Remember when we talked about rational and irrational numbers? All right, so rational numbers and irrational numbers really belong to the same family of numbers. They're called real numbers. All right. There's also imaginary numbers, which we aren't going to get to in this class. That's higher math, but right now we're dealing with real numbers, and those can be broken into rational and irrational numbers. Rational numbers are simply numbers that can be expressed in fraction form, so A over B. Okay, so you've seen, we call them natural numbers. Those are just your counting numbers, 1, 2, 3, 4, 5, and up. Integers include the negatives and 0. And then rational numbers, you see, can be decimals, fractions. They can be whole numbers, but they can be written as fractions. So 0.75 can be 3/4. These are repeating decimals are considered rational numbers, and terminating decimals are considered rational numbers. Irrational numbers, on the other hand, cannot be expressed as a fraction. They have decimals which do not terminate, so they don't end, and they do not repeat, so they're kind of random. All right, so a lot of these are rational or irrational, are radical numbers. Okay, a lot of radicals are irrational numbers. Pi is another example of an irrational number. Okay, so make sure you understand the difference between those. We're going to check it right now. Determine whether each number is irrational or rational. So go ahead and pause the video, see what you think. Hopefully you've paused it. We'll reveal what we get for the answers here. 7 over 13 is a fraction, making it rational. 57%, I can write that as a fraction. That's 57 over 100, which makes it rational. The square root of 7, if you type that in your calculator, it's a really big decimal and doesn't repeat, doesn't end. It's an irrational number. Now, a lot of people think that every radical number is irrational. However, some of them simplify nicely. The square root of 16 is 4, or 4 over 1, which is a rational number. That's why you have to know how to simplify these radical numbers, which is what we're going to be doing this week. So some terminology that we need to make sure we understand. The radical symbol is there in green. The radicand is the number underneath the radical. And then there's an index, which is right here. Now, if there's no index there, we understand it to be 2. We say square root. But as you get to higher math, you're going to see third root, fourth root, fifth root, and so on. Okay, so you need to understand that that is an index there. All right, so this week, we're going to take a look at simplifying square roots. So let's take a look at square root of 7 right now. Like I said, if I type that in the calculator, you're going to get this big, long, nasty decimal. To work with that, we would have to round it before we can really do much with it. I can't write all those numbers. They don't end. I cannot write all of the decimals that are made by that number. So we have to approximate it. So 2.65 or 2.646 or something like that. We have to round it. Now, when we round it, that causes our measurements to be off at times. So we like to work with exact numbers. So we have to leave things in simplest radical form. So the square root of 7, I really can't do anything with. Simplest radical form would just be the square root of 7. And we'll work on that this week. All right, so this week specifically, we're going to learn how to break down radicals. We're going to learn how to multiply radicals together and break them down from there. We're also going to learn how to divide radicals. All right, so this week, we're going to simplify radical expressions, and I'm going to break that into 2 lessons. We're going to multiply and divide radical expressions. So let's get started.